All right, so we want to talk about some of the earthquake exercises. So maybe we'll talk about 23 first.
Okay.
So this is 11 point, what,
7.
723?
Yeah.
Okay, so we want to know about this earthquake, right? And they gave us this formula. R is log of A over A, right? Okay, so if we go back and look at the section for this, figure out that R is log of A over A means, what are these guys?
So one amplitude.
They're amplitudes. So this is the amplitude of the quake. And this one is the amplitude of the reference.
What's the reference?
That big number?
No, the reference is, so here they're saying, all right, the amplitude of the September 19th, 1985 earthquake in Mexico City was blah, blah, blah times the reference amplitude,
Oh.
right?
Okay.
The reference amplitude for reference is extremely, extremely small, okay? The reference amplitude is a nanometer, which is a millionth. Million? It's 1 over 10 to the 6th meters. A millionth of a meter. So you start with a meter, right, which is about yay big. A tenth of a meter is about yay big. A tenth of that is we actually have a word for that thing. You guys know what a hundredth of a meter is called?
Centimeter.
Centimeter.
Oh.
Centa meaning hundred. So a centimeter is about like this. That's a hundredth of a meter.
So what an inch?
A thousandth of a meter is a millimeter. Right, and the reference amplitude is a millionth of a meter, so it's a thousandth of a millimeter.
That's very small.
Yeah, they're very, very little. You can't feel that order of movement. You really kind of can't. So, which is why nobody cares, right, until earthquakes reach about 3 or 4 on the scale. Because you can't feel 1 and 2s, they're really nothing. When you get to 3, right, then you're getting into the millimeter range. 4 is a centimeter range. 5 is this guy range, right? If the earth moves that much, you can feel it, right? Okay, see that? If we hit a 6, right? That's when we're talking about a meter of movement. A 6 is enough to throw you on the ground.
Kind of like what was San Francisco in like 1919.
So big destructive earthquakes are basically above 6. If they hit a population center, sometimes a 6 is enough to really cause some havoc, right? So if we want to talk about this one, this is a Mexico City quake. I want to calculate the magnitude on the Richter scale, right? Okay, so I've got 63, whoa, that's a lot, times the reference magnitude, right?
Right.
Okay, so what's the Richter scale? What do?
What is the formula?
Yeah, I just used the formula. Okay, so if it's 63 million times the reference,
Was that R?
yeah, okay, so I want to figure out R, right? So R is log of 6310000 times what?
A over A.
Times A, right? It's that times the reference amplitude. So it's that times A. And then in my formula, I divide by A.
8, but the letters should be capital.
No,
No.
this whole thing is a capital A.
Then why do you put a lower, oh, no.
Notice the A's cancel, right?
Oh.
Can you see that?
Oh.
So now I've got log that I can take, right? That's log base 10 of a number. So what do you get when you do that?
You make a log base 10.
Yep, so it's log base 10, right? So it's going to tell me how many powers of 10 go into making this thing. So I can see that it's 1, 2, 3, 4, 5, 6, 7, 8, 7.8, right? So someplace around 8. You guys see that?
Did you divide that by 100? 63 million?
No, I did the log of it. So it's counting how many zeros are there on this number,
Oh.
right? How many powers of 10 is this thing? And I know that it's between 7, right? Because 7 would get me to here. And 8, because 8 would get me to the next, 7 would get me to here, 8 would get me there.
And can we call it places instead of 8 zeros? Can we just say places? Or is that no?
I wouldn't say anything. I would just log this number and get 7.8. So this is 7.8 on the Richter scale.
So I'm going to put log.
You guys see that?
Yeah.
Log of this will give you 7.8. You guys cool with that?
Well, let me test it out.
I don't understand why we don't have a sign, like in Mexico they have a siren now that tells them in 90 seconds to get out.
I don't know.
That's pretty good.
I don't know why we don't have an earthquake siren.
So what-
Okay, so what if I did this one 24? Can I do that? If it's,
It's the same thing.
oh yeah, it's basically the same thing, right? Okay, so what do I do? What's the answer to 24? Should be log of that 20,000 number, right? Which gives me 7.3.
Point
You guys see that?
Nice.
Notice that the difference between a 7.3 and a 7.8, right,
Yeah.
is a difference of
This two.
a factor of 3, right? You guys see that? So this earthquake is 3 times more energy, right? 3 times more powerful. But they're pretty close together on the Richter scale, right? You guys see that?
What?
What?
But you can naturally just look at that and say, oh, it's going to be 3 times more because
Yeah, it's going to be 3 times more, but that's not the relationship between these two numbers, right?
okay.
These two numbers are only different by a half a unit. You guys see that? What's a difference of 1 mean? So if I go from 7.8 to 8.8, what does that mean? Not 6 times.
The 10 to the something.
10 to the something.
6. No.
So, right, the log's measuring how many 10s do I multiply together, right?
Right.
If the log goes up by 1, that means that the thing you were talking about went up by a 10. See that? So the difference between a 7.8 and an 8.8 is a factor of 10. Right? The earthquakes we were talking about when we started, we said, okay, a 3 is a centimeter. A 4 is 10 times that. It's 10 centimeters.
Okay.
That's going to be a no.
5 is
A decimeter. Yeah. And a 6 is 10 times that, right? That's a 1 meter. See that? Did I say a 4? I said a 3 was a centimeter, didn't I? I meant a 4. 4 is a centimeter, 5 is a decimeter, 6 is a meter, 7 is 10 meters.
Wow.
This guy's almost 100 meters. What's a 9? A 9 is 1,000 meters, which is a kilometer. 9s are really, really big, by the way. The Earth moves a kilometer, right? That's like from here to across the pond. That kind of shape destroys everything.
Anything higher than that?
Which is why the Richter scale, right? For all intents and purposes, goes to like 9.5. Because
Have we ever had-
12s blow up the planet, right?
Have we ever had a 9?
Yeah, 9s have occurred.
Hmm?
9s have occurred.
Not here.
In
Alaska.
Not in an inhabited area, to my knowledge.
Okay.
These are big things. These are things that you feel essentially across the face of the planet. 9s are
They're the
big.
ones that cause the tsunamis, right?
Yeah. 9s cause really nasty tsunamis if they happen anywhere near the ocean.
Which everything is kind of near.
Yeah, and in the order of magnitude of a 9, everything is pretty close to the ocean. Okay, so
Good damage.
do we want to do 25 while we're here?
Yeah, yeah.
Okay, so,
Oh, wow. I think it
Whoops.
was this long.
okay, 25 says, the damage done by an earthquake is related to its magnitude, the population, and the quality of buildings. Okay, yeah, duh. Something about a turkey. It's a number 7 worst natural disaster ever to occur.
Okay.
Okay. A 7.4.
A, the little a now?
So 7.4 on the Richter scale is the answer we got out of the log of the big A over the little a. Right? That's an R. So this 7.4 is this earthquake in Turkey, right? And then they're saying, okay, that's the biggest one to hit a city since the 1906 San Fran earthquake, which was estimated to be an 8.25.
Jeez.
And now I want to know how many times more intense this was. Right? So, how far apart were they on the Richter scale? How about that, for starters? So, the difference on the Richter scale between 8.25 and 7.4 is what? Yeah, just subtract. So what's 8.25 minus 7.4? 0.85. Okay, so that's 0.85 different. And remember, these are logs. So these are talking about, these are different by a factor of 10, almost 10, right? 0.85. So that 0.85 is, we should put that in the exponent of a 10 to figure this out. You guys see that? Because this is talking about how many multiples of 10 are these two earthquakes different. They're different by 0.85 of a multiple of 10. So I want to know about the number 10 to the 0.85.
And that's going to be
What's that?
0.07.
8.07?
No,
Say?
negative 0.07.
Yeah, well.
No,
Oh,
it's definitely not negative.
then I did it.
So you're probably doing log of this. I want 10 to the 7.07. You guys see that? Okay, so what do I say? Calculate how many times more intense the 1906 earthquake was than the 1999 Izmit quake. So I found out that they differed, right? The logs differ by a 0.85. So the thing must differ by a factor of 10 to the 0.85. So I get 7.07 times more intense. You guys see that? Cool. you want to see the mathematical justification for that, or are you okay with this is factors of 10? Okay. You can use a log rule actually to see this, but let's leave it at this. This is counting how many 10s there are, and they're different by 0.85, so we get 10 to the 0.85 difference. You guys see that?
Okay, when you say 7.07,
Times more intense. What I mean is that the Earth moved 7.07 times further. So if things shook by, I don't know what this was. This was 7.4, so that's a lot. So that's like 30 or 40 meters movement. This shook 7 times harder. So if that was 30 or 40 meters, this is like between 210 and 280 meters, or yeah, 280 meters. You guys see that? So yeah, that's a big difference, right? So 1 unit on the log scale, 1 unit on the Richter scale, right, is 10 times more. So the difference between a 6 and a 7 isn't like a little bit, it's like a lot, right? Cool.